Okay, so good morning, all of you. So first, before starting my this intro course, okay, so we need to know about the brief idea about this course means what is the actually what is switch mode power conversions or the significance of this course. Okay, so all the most important before starting that details instructions about this topic. Okay, about this subject. So today is the introductory class. Okay, so that's why we are that's why we are discussed about the basic ideas of switch mode power conversion. So you can get that. I have already uploaded. I have already uploaded my slide, so you can understand what is the basic importance of these subjects and what are the most important topics of these subjects. Okay, so that's the basic motivation. So first, we need to start with that. What is the before starting any of the subjects? So we have to know about different important points. So what are the most important points? So we have to know about that what, why, and how. So first, we need to know about what is switch mode power conversion. So first point, but I think if you all of you are already because it's a post graduation course. So what is the basic importance? Okay, that's the most important part of this chapter. So what is switch mode power conversion? So from the title, from the idea of the title, so we can understand that switch mode power conversion means that switch mode. So what is switch mode? That means normally we know about that the power electronics and non-electronics devices are there. It will be different switches. So what are the switches? It may be different, it may be MOSFET switch, it may be JFET switch. Okay, so it may be it may be other transistors like BJT. Okay, so all the switches, oh sorry, all the transistors on that solid state devices. Okay, in very online you can see like that all the solid state devices are acting like a switch. Okay, that's the most important thing. So why it is called a switch? Switch means what? If you see that solid state device, okay, and if you want to draw the characteristics of that solid state device, you can understand that there are different zones of operation. Okay, so you can know that initially there is some cutoff zone. Sorry, there is some cutoff zone. Okay, after that, and some active zone is there. Okay, beyond the active zone, there is a saturation. Okay, so normally three zones are there. So okay, so if you go, your device may operate any of the zone. Okay, so saturation zone and the cutoff zone means what? In this zone, the switches, that means the solid state devices are normally off conditions. Okay, so normally off conditions. Okay, so that's why you can say like that. And rest of the zone is active zone. Active zone is when the solid state devices directly carries some of the current. Okay, so if you see this MOSFET, you know about that important thing that is called RDS, resistance between drain to source. Okay, so RDS, when you are looking the parameters of individual switches and individual solid state devices, the technical terminologies like RDS, what is your maximum voltage, switching frequency, okay, so other different features also be there, PIV, okay, so that should be mentioned in the data sheet. So because of what? If you don't mention them, then you are not able to understand how much power losses you can observe when it will be connected with your circuit. Okay, so if MOSFET is directly connected as an active zone of your circuit, then what happens? Not it's having less relatively less resistance spike because it's a solid state device, that is semiconductor device. So it having a huge current flowing through this MOSFET. So that may cause of what? That may cause of I square RDS on loss. So it's a huge amount of current loss, huge amount of power loss. Okay,
Sir,
that kind of power loss. Okay. So that may cause for
the audio is not.
that may cause for unnecessary losses in the system. So what is the basic motivations for changing the solid state devices making the solid state device as a switch? Okay, that's the basic reason. If your solid state device are turned on normally or the turned off, that means if it is working on the saturation level, otherwise it is working as a capability. So you can say like that only two state of operations are there. That's why it is called switch mode operation. So in switch mode power conversion, okay, so we are using all the solid state switches in which domain? In only for cutoff region or saturation. What is the basic reason? Okay, because it's like a switch, and is on, otherwise off. Okay, so in cutoff region, what happens in cutoff region? You can say like the switches that means the solid state device is normally open. Okay, currently there is no such current is flowing through this part. Okay, normally it is open. So you can say like this, you can say like that. So there will be no current flowing through this solid state device, but voltage will be there. So how much power loss will be there? So thinking about that expression, V into I. So if there is zero current flowing through the solution path, zero current flowing through the solid state path. So how much current will be there? How much power loss will be there? V into I. So V you have some of the value of V, but I is zero. So V into zero equals to V. So total power loss is zero. Okay, and and in case of sorry, saturation region, what happens? In saturation region, if you will see like that, in saturation region, you can see that the current will be flowing over there. Okay, the current is continuously flowing, but there is no such voltage difference because in short circuit path, what happens? In short circuit path, there is no such voltage is zero, but current will be full load current. Okay, so finally, what happen? What will be your power loss? The power loss will be V into I again, that will be zero. Okay, that's the basic motivation. So why that switch mode power conversion is why the switch mode power conversion is considered. Okay, so that's the basic thing. So that's the basic motivations about that. What is first we have already discussed what is switch mode power conversion. Okay, now we have to discuss about why is it so important. That I have also telling you that because the main motivation is reduce the power losses in the solid state devices. Okay, why such kinds of losses are important? Because if you don't reduce such amount of losses, so you know about the solid state device always having solid state device always having huge current carrying capability. Okay, so otherwise it will you can observe huge loss. So that's the basic reason. Okay, for conversion our conventional system into switch mode conditions. Okay, and how? Okay, so how means I have also discussed how we are going to be focused to our as a switch mode configuration means you can say like that um, what will be the switching pulses. Okay, but who will decide such factors? Okay, so you know about that, you know about the different solid state device having different properties because as per the properties means you know about different solid state devices name like your all of you are very aware about that SCR silicon control rectifier, that the thyristors. Okay, these are the latching device. Okay, and sometimes you can know for that BJT, that means power BJT. Definitely, it maybe behaves like a solid state device. It maybe behaves like a
switching device. Okay, that's it's a BJT. Power BJT is a solid state device. This maybe behaves like a switching device or the linear power supply. Two things are most important. One is called linear power supply, another one is called switching power supply or switch mode power supply, SMPS. Okay, in linear power supply, that solid state devices are working in what the solid state devices are working on in the active region. Okay, that's the basic difficulties in linear power supply. So if the current is flowing through this active region, so huge amount of current flowing through this circuit, so that may cause significant amount of power loss. If huge amount of power losses are there, so you have to making the coolant. Okay, you have to introduce some of the coolant with your solid state switches that may mitigate or that may dissipate that energy generation or power generations. Okay, otherwise your devices will be burned out. It's a huge power loss will be there. Okay, so the heat sink, I think all of you know about that heat sink. Okay, so heat sink size in case of linear power supply too big. Okay, so that's why it is not so significant. But initially, if you going for that high rated power supply, that also be the example of that linear power supply. But in case of switching power supply, inherently by the property of these devices or the inherently by the property of this logic of that power supply, you are making the power loss is zero. Okay, that is the basic benefit. Okay, and how would you make that system in the switching mode? Okay, how to make that solid state device as a switching mode? Okay, so it depends upon your different logic. Okay, maybe sometimes control logics. Okay, so PWM logic, how do you converting all those things to the PWM, how do you controlling everything to the PWM technique, that also been discussed in stepwise. So it's a very first class, so I am giving the very brief about our subjects. Okay, so first we need to know about what is the importance of that subject, and why it is important, and how we are going to be implemented. Okay, so I think all of you have a brief idea on it. So what is switch mode power conversions? Why it is called power conversions? Because you know that power, actually the converters which are processing the power. Okay, so the power electronics converter normally the processing the power input side and the output side. Your input side having maybe AC, DC. Okay, your output side having maybe AC, maybe DC. So what type of power conversions are what type of possible power conversions are available in the system? Maybe so AC to DC power conversion, or AC to AC power conversions, or the DC to AC power conversions, and DC to DC power conversions. Okay, so that's why it is known as that power conversion. So power converters means which are responsible for conversion or the converting the power conversion is what it is responsible for conversions the power from one form to another form, not one form to exactly, maybe the demand as per the demand of our the system demand. Okay, so that means decided as the demand of our systems. Okay, when that AC to DC conversion is required, because if your input is AC, so definitely, so as per your demand, if your input is AC and output is DC, so you have to prepare one converter. Okay, so where the power conversion will be from AC to DC, so that is broadly known as rectifier circuit. Okay, so all of you know about it. What is that is broadly known as the rectifier circuit. If your input side power is DC and required power is AC, then what you can say like that, your input DC, so you can convert it to AC power. Okay, so it's a DC to AC power conversion. So there. Okay, so normally that type of power conversion is known as inverter. Okay, so similar kinds of thing also be there. AC to AC power conversions also be there. Okay, the AC to AC, in case of AC to AC power conversions, so you can say like that two things are most important. One is there any changes of the magnitude? Okay, because input is AC, output is also AC. So if there is a changes from the input magnitude to the output magnitude, that is number one. Number two, is the frequency is changing from input AC to input AC, AC input to output AC. Is there any frequency changes over there? That you have to check. Okay, so from a fixed AC to variable AC, you can say like that. From fixed AC to variable AC, without changing that frequency level, you can say like that. It's a AC voltage regulator. It may be single phase, maybe three phase. Okay, and another thing, single AC input to variable AC with having variable frequency. So what is known as that type of device? That is called cycloconverter. Okay, so input is your AC, output also be your AC, but the frequency and the magnitude of your output AC will be deferred. Okay, so will be variable. Okay, so you have such possibility, so you can. So that is the example of AC voltage regulator. Okay, sorry, cycloconverter. Okay, same thing, your input is AC but output is DC, so it's a rectifier. Sometimes you can use directly direct rectifier, sometimes you can use the control rectifier. Control means it may be full control, okay, it may be semi control. Okay, you know the configurations. If you are converting, okay, so you are converting from AC to DC, again there is some possibilities are there. Half wave rectifier, okay, only half cycle it will be implementable, implicable. Then full wave rectifier, only full wave means full of the cycle. That means in half wave rectifier, for positive half you are using, negative half you have omitting. Okay, but in case of full wave rectifier, positive and negative both of the half are you are rectifying. Okay, so you are getting some pulsating DC. Okay, so that is your full wave rectifier. Then you can see that bridge rectifier you can also be used, okay, for making your system convenient, much more convenient. Okay, in case of bridge rectifier, again the full conversions will be there, means all full control rectifier will be there. Sometimes you can say like that half control or the semi control. Okay, so all the four bridge path, if you are preparing by the control switches, so you can say like that it's a full control rectifier. If one of the switches of individual arm having on uncontrolled switches, maybe you can say like the diode, so it's a semi control rectifier. Okay, so you are converting from DC to AC, sorry, AC to DC. Why you are converting? Because you having some why you are converting? Because your input is AC but output is DC. That is your requirement, that's why you are converting. Okay, I think you are able to understand. Then last thing, if your input is AC, output is also be DC, it's also possible. Okay, so it's an example of inverter. If AC to DC conversion, please hold on. Okay, I'm just. Okay, so in case of AC to DC conversion, I have already told what is known as, it is known as normal inverter circuit. Okay, so your input is sorry, AC to DC conversion is your rectifier circuit. Then if your input is DC but output is AC, that means required output is your AC. So that circuit also known as inverter circuit. So in case of inverter circuit, you can see DC having fixed, DC having magnitude, okay, and AC also having magnitude as well as some phase angle. So who will decided that phase angle? Everything will be decided. So in case of inverter, if your input to output conversion, so magnitude as well as the frequency both may be varied. Okay, so if you are having some of the fixed magnitude, you are going to be convert over there, so both may be varied. Okay, so as per your requirement. Okay, so and last one, if input is given input is DC and your output also be DC. So it is called DC to DC converter. Okay, so you can vary, you can step up from your input voltage, input DC voltage to output DC voltage. You maybe step down from your input DC to output DC. Okay, or both of the cases also being possible. So sometimes you can step up and step down as per your switching logic. Okay, so if both of the possibilities are required, maybe in buck boost converter. Okay, so if you vary the pulses of the duty cycle, and finally you can finally you can convert so as per your requirement. So you can understand from the entire discussion, okay, all the discussions, I think we are able to understand what is the basic motivations of the switching converter. So we have solid-state devices and uses like the switch, okay, that can convert your input to the output power, that can the power may be processed from your input side to output side as per your requirement, and that logic will be developed by yourself. Okay, that's the basic motivations of this subjects. Okay, so now we have to discuss about the syllabus. Okay, so syllabus of this subject, that is another most important thing. So what are the most important things for this syllabus? So there are several modules. Okay, so first module is your switch mode power conversion module. Okay, so in this module we are discussing about that overview, introduction to the DC to DC converter. Okay, so switch mode power conversions means always it will be DC to DC converter, is not right. Okay, so in that case the converter is much more, the converter is, that means the solid state switches are uses like a switch. That is most important. Okay, so it may be DC to AC converter, it may be DC to AC converter. Okay, so as per the requirement, but in our practical cases normally we are much more bothered about DC to DC converter in this switch mode power conversion chapter. So most of the cases the DC to DC converters are used. That's why we are much more focused about the DC to DC switch mode power conversion. Okay, so
First module one is introduction. That I have discussed over. I will also discuss some of the important points about some topologies of the power conversions and other pieces. What are the different types of converter and everything. Next module you can say like that it is the power semiconductor sequence. Okay, so where we discuss most important power semiconductor devices that the solid state devices which are practically used in our switching converter circuits. Normally we can say like that I have already told you that normally we have used the MOSFET, okay, and the IGBT, okay, MOSFET, IGBT, and sometimes we are using IGCT. Okay, IGCT is very very costly device and there is some dedicated solutions for IGCT. And we are much more focused about in our practical cases. Okay, so in our laboratory, okay, for designing of switching converters, so we are using MOSFET and IGBT. Okay, so in DC converters, especially we are using for MOSFET, and in case of inverter circuits, we are normally using IGBT. Okay, so the characteristics of the solid-state devices, that means the switch mode solid-state devices, okay, that is also important. That we will discuss in module 2. In module 3, we are going to discuss the modeling of the converter. Okay, so that is most important thing. Okay. So what do you mean by the modeling? Okay, so I think you have some idea about the modeling. Okay, so what do you mean by the modeling? So modeling means what? Modeling means from where you are having the vulnerability. That is also important because modeling is related to the physics. Okay. So what is the significance of this modeling of this converter? That we need to know first. Okay, what is the motivations of the modeling? Okay, so first you know about that we are using the solid state devices, okay, as a switch. Okay, so if we are using the solid state device as a switch, so which type of nonlinearity is going to observe? Definitely it has, if you see the characteristics block of that solid state device, you can see that initially it is the current region, then active region, after that the saturation. Okay, so then what happens? So if you see, usually the curve are non-linear in nature. I think so. Okay, so if you see the IV characteristics of the diode, you can understand the pattern of the diode. Sorry, that you can understand the very voltage. Okay, the current pattern of the diode. So it's not the fully linear. Okay, some of the portion is linear, but most of the portions is non-linear. Okay, so in that case, you can say like that the functional devices are used like the is in the active region. Okay, so it having some of the non-linear properties. In active region, normally it's a linear condition. Okay, so that's why it is called a linear power supply. The power losses is too huge. Okay, in linear power supply because of what it is working in the linear region. Okay, means it's a fixed resistance part means totally RD1 means RDS. RDS on means resistance for derivative source of the MOSFET. On means it's a very less resistance that may cause a huge convenience. Okay, so this significant amount of power losses is observed in the linear power supply. But in case of switchgear power supply, the solid state device it may be turned, may be turned on. Okay, there will be no significant amount of power loss. Very little significant power loss will be. Okay, so you can see like that what type of nonlinearities are there? Switch on and switch off nonlinearity. Okay, this type of nonlinearities is observed in normally support power converters. Okay, so if the nonlinearities are there, so when you are going to design the controller means what? Because you are maintaining the regulations of the system. So what is the regulations? Okay, that also is there. Okay, normally we are checking voltage and current regulations. Okay, normally we are checking voltage regulations. Okay, that means output voltage regulation and input voltage regulation, reference tracking. Okay, that also is the most important terminologies. That is also related to your robust stability. Okay, robust stability means sensitivity of the systems as well as the robust stability. Okay, so what is that? What is that? The meaning of this terminology? You can take one example. I'm just considering. Okay, so in all the cases, what happens if you have some system? Okay, so you can. I'm taking some practical example. Then I'm going to take some inverters applications of this. Bring it to this example. Okay, so what was your example that you can say like that you have some hot bowl. Okay, so you have some hot bowl because you know about that and few days back there was some huge there's some lockdown in our country, so most of the person, okay, so all are very busy for cooking and everything. Okay, and so when you are in your kitchen, I think so you can see some hot and for there is some hot boil is there, and sometimes you miss your attention, so you just touch that bowl. Okay, you just touch that bowl. Then what happens? So if you touch that bowl, then you can if it is if the heat is if the temperature of the bowl is too high, so what happens? You suddenly remove your hand, but how the practical system is going on? Okay, so normally what happens? Normally when you are just touch your fingertip to the bowl, then your fingertip having lot of temperature sensors or the heat sensors are there. Okay, in our skin. Okay, so it will sense the temperature. Okay, it will sense the temperature, and that temperature that means that signal. Okay, so that temperature is converting to the signal because you can say like that. This is sensor. Okay, sensor or the sometimes you can say like that the transducer. Okay, so I know you know. I think you know about the difference between the sensor and transducer. Okay, so in sensor, any of the physical parameter or different parameter will be there, and it may be the physical parameter is there. It will be convert electric electrical signal or other signal. Okay, but in case of transducer, it will be mandatorily convert the electrical signal. In our courses, we are also using lot of transducers. Okay, like voltage transducer, current transducer, voltage transducer, we can using LEM. Okay, LEM transistors we are using 25 P. Okay, 55 P. So different transistor we are using for the voltage as well as some current. So LDO means it's a Hall effect transistor. Hall effect transducer. Okay. So uh, in our practical field, means in our body also, so we are sensing that temperature and it will be converted to the signal. What type of signal? Electrical signal. Okay. Then the signal will pass that signal to your hand to brain. Definitely the neuron will be there. What type of neuron will be there? It's a sensory neuron. Okay. So sensory neuron will pick that signal from your sensor, that is from your temperature sensor, and it transmits the entire signal to your brain. So brain having processing unit. Okay, so processing unit means there is predefined part, predefined fixed value of the temperature. So how much value is tolerable, how much amount of temperature is tolerable by your hand. Okay, that means it's not like only hand, it's the body, because entire the body is the outer membrane or outer surface of the body is more or less same. Okay, because there is no such discriminations for the skin of that hand and the skin of the leg. Okay, definitely some of the discrimination is there. The thickness is different. In the thickness of the hand skin quite less compared to your leg, because your leg is always touching with your with that arch, no? So that's why the thickness is different, but material is more or less same. Okay, so material is same, and definitely the thickness has changes, and many different temperature changing threshold value also we change. So that threshold value is stored in your brain. So then it will be compared. Okay, comparing with the threshold value and the sensing value. Okay, so how much difference is there? So how much error is there? If the error is big, what type of error? So your reference signal is there, that is given, that is your threshold value is given, is already there in your brain. And what is your measured signal? Measured signal means measuring done by your skin. Okay, and the skin of your hand. Okay, so how much error is there? So if how much differences are there? So if error is, if this error is significant, then what happens? Sometimes some error is there, so brain is trying to mitigate such error. Okay, mitigate such error means it tries to reduce the values of error. Okay, then what happens? It will get some signal. Okay, if it is say that error is too high. Okay, means error is too high means that your error is too high means that your laser temperature is too high. That means it is beyond your body temperature. So what is your body temperature? Normally in human being it is 98.4 degree Fahrenheit. If you convert to the centigrade, I think it is 33 or 36 degree centigrade. So you have to check that, you have to convert that one. Okay. So if it is beyond that predefined value, then how much beyond? Okay, if it is a tolerable value. So if you see that register, okay, that solicited register in your lab, so there is some gold line, silver line, so gold ring, silver ring. So it will define the tolerance. Okay, so error tolerance on the register. So brain also defining how much error it will, how much temperature it may be tolerated by that skin. Then whatever, if it is in tolerating region, so there will be no problem. If it is beyond your body temperature, then what happens? Then it will send a signal to your to your what? To the hand. Okay, the muscle of the hand through the motor neuron. So motor neuron will taking the response from the brain to your hand. Hand means your hand, muscle of the hand. Okay, then it will signal, the motor neuron give the signal to the muscle, please remove your hand. So that means the control, that means the processing is done by the brain. That is the most important working in the control signal. Okay, that is your control idea. Okay, and that's your control idea, and the signal, that error signal also be there. That error signal will be compensated by the control. Okay, and by the controller, and finally we get the control signal. That control signal is coming from your motor neuron to your hand. So not like hand, the muscles of the hand. Then it will be instructed to the muscle to remove your hand from the hot ball. So muscles is what? Muscles is your actuator. Okay, so what is the actuator? Actuator means that the controller is give the signal to the actuator to do the platform. Okay, so you can see that your actual muscles in your actuator that give the signal to the that actually shrink, okay, and it will remove that signal hand from your or bowel to the fluid space. Okay, so you can understand. So same thing also will
Sir,
happen
your
for
audio is
the
not clear.
same thing also will happen for the regulations of your converters. Okay, so regulations will what happen and there is some output voltage. Okay, always it will be some kind of fixed. Okay, so different type of control is there. Voltage mode control, current mode control. Okay, another mode of operations, continuous current operation, discontinuous current operation. That will be coming one by one. Okay, so in case of voltage mode control, so you are giving some of the voltage. You are measure the output voltage of the converter. Okay, so power processing unit, that means your converter, and you have some set value, means you have some reference value. If your output voltage is too high, okay, suddenly how it will be possible, or how output voltage will be low, because there is some load. Okay, you know that in all the cases the power processing unit, the input power and output power is always fixed. Okay, so in some situations we appear, that's why some of the in both of the cases are power output. So how the voltage output voltage is high, that means some of the current. Okay, due to load is some of the current, there is some difference of the current. Okay, suddenly deep down of the current will cause for increase of the voltage. Okay, if the output voltage is high, then it will be compared from the same value. Okay, so say from the reference value, then you can see some of the positive error will be there. So we have to minimize that error. Okay, by controlling the operations of the solid state device, means switch on and switch on and switch off device by controlling the switch on timing and the switch off timing of the solid state device. Okay, so you can realize the problem. Okay, so how do you realize it? So output voltage is high. Okay, that is comparatively big from your fixed value of voltage. Okay, so that may cause for the positive error. Okay, so positive error is there after getting the positive error means differential amplifier. Okay, in differential amplifier, input is one input is coming from your reference signal. Okay, another signal is coming from your measured signal. Okay, so from the differential amplifier you are able to measure that error. So some error will be generated. That error will be what? That error will be passing through the controller or the compensator circuit. So how much values of error is compensated by the controller or the compensating circuit. So we get some control signal. Okay, after getting the control signal, that control signal will be compared. Okay, will be compared with some repetitive signal, or you can say like that. Sometimes you will compare with the triangular signal. Okay, in voltage mode control. Okay, so after comparing, why you are going to compare that control signal to triangular signal? Because you know that your switch is normally getting the pulse. Okay, pulse. So how to get that pulse? Definitely you have to, because your control signal is more or less fixed voltage. Okay, or slightly changing voltage. Okay, it is normally fixed voltage or very slightly changing fixed voltage, where it is changing very slightly frequency. Okay, so frequency is to time period is, you can say like the frequency is high, which time period is low. Okay, so you can say that more or less constant voltage. Okay, so constant voltage, how to make that constant voltage to the feedback bill? So you have to convert that constant voltage, sorry, you have to compare the constant voltage with some of the triangular voltage. Or sometimes you can say you can use the sawtooth voltage also. So you are comparing both of the voltage and you will get some pulse. Okay, that pulse will be passing through the driver circuit. You are not able to give that pulse directly to your switches. Okay, directly to your MOSFET switches. Okay, any of the switches. Definitely there is some standard driver circuit. So standard driver circuit means that pulse is having is not sufficient for providing how much voltage strength and how much current strengths are there. Okay, so sometimes what happens, you have to amplify the voltage and current strengths. Okay, so there is some control circuit using some of the basic analog circuit. Okay, for in the driver circuit to drive the solid state device. Also, the solid state device is having some of the protection circuit. Okay, then what happens? That pulse will be there. Okay, so pulse is driving your solid state device. Okay, if the control circuit is varying, okay, then what happens? You just realize the problem. Okay, the control circuit is varying. and your triangular waveform is fixed, but it is varying. Control circuit is varying from the height in between the height of the triangular wave. By the varying of the control circuit, the pulse width, okay, the pulse width will be changing. Okay, will be changing. Okay, so if your voltage is high, okay, so error will be high. Definitely, the control signal will be towards the high positions. Okay, so here the logic will be like that. Okay, so if the control signal will be towards the high position, so pulse width will be less. That means you are instructed. That means your control circuit is instructed to the solid state device for you have to turn on for the lesser amount of time, for the less time you have to turn on. So if it is turned on in the less time, so what happens? Directly the voltage will gradually be reduced. Okay, that's the way you are maintaining the regulations. So what type of regulations you are maintaining? Output voltage regulations. Okay, so similar type of process, it is called the feedback control. Okay, it is called the feedback control. Sometimes we are also using input voltage. Okay, we are making fixed of the input voltage. Okay, any of the variations we are making fixed output voltage by the variations of the input voltage. That also known as the feed forward control. Means in input side we are controlling the entire process in the input side. Okay, so different type of controlling techniques are there. So one by one I am coming. That will be discussed in your module 4. And in module 5, we are going to discuss about the design of the magnetics. Okay, because you know that all the most of the cases you can see in the switching converters having a lot of magnetics, mean ferromagnetic cores are there for the what for the designing of inductors. Okay, because it having some energy storing elements, capacitor and the inductors. Okay, so in case of capacitor, there will be no problem. Okay, that is the standard values of capacitors are available in the market. But in case of inductors, you have to design. Okay, you have to design the inductors by using different magnetic material. So, what type of magnetic material you have to be selected? That will be discussed. Okay, what will be the core nature of the codes? It is E code or it is EI code or it is E type code. So what type of different codes are there? That also we discussed. Okay, so because most of the cases the high frequency operations are there. Okay, so how much values of how much type of different codes we are going to be used, that will be discussed in the magnetic circuit. And finally, we are going to design some design, going to work some design exam. Okay, so for designing a switching converters. Okay, so by using different magnetic circuit, by using different magnetic circuits, so what are the magnetics we are going to be designing, what are the number of terms, okay, in the magnetic circuit. Then finally we will design one converter. Okay, so on the cases in the throughout your course, okay, another most few important ideas are there. Throughout the course, there is some mini projects also there. Okay, so calculations you have to do. Okay, one by one I am coming. Okay, I think the marks distribution. Okay, so I think this is the very basics idea of our syllabus, and then you can go for some reference studies. Okay, what are the most important books you need to follow for the subjects? Okay, so you can follow that. You can follow different standard books. Normally, we are using following power electronics and what application design by Lead Mohan and then and William E. Robbins. Okay, that's very good books. Then we can also use some of the books like what W. Erickson's and Nestanovic. Okay, that book also be very good. Another book also be there for the power electronics, that elements of power electronics. All the books also cover the suite of power converters. Okay, so in very well manner. That's why I'm following some books. Okay, and last book is Elements of Power Electronics by Philip Chicken. Okay, another supplementary reading different books also be there. You can go for supplementary reading. Means it's a referring book. First one is your essential books, and next one is your supplementary reading. It's a reference book. You can follow such books for the reference guide. Okay, but mandatory you have to go through these three books, apart three books, first three books. Okay, because you are from the PED group. No? So PED group means you have to get a good idea about your power electronics. Okay, that's why it is most important. Okay, So that is enough for today's discussions. Okay, so then this is enough for today's